Alright, so in this video, we're going to be talking about the properties of the cross product, okay? Now, the properties of the cross product differ slightly from the properties of the dot product. One major one is that A cross B equals negative B cross A. And it's not just that, you know, like A dot B equals B dot A, right? That makes sense. But A cross B is actually equal to negative B cross A. Okay, and let's see why that is. If you had, let's just kind of do a little, this isn't going to be like a full proof or anything, but I'll at least kind of give you the gist. Let's say we have this 3x3 matrix, okay, and this is trying to find the cross product. So, of course, our second row belongs to vector A, and our third row belongs to vector B. Okay, this is A cross B. Now, if we, let's just find what the what's going to be attached to the I hat here when we find the determinant. Okay, AD minus BC. Okay, so AD 1 times 4 is going to be 4 minus, we have a 3 times 2, that's going to be 6. Okay, here we get a, and this isn't the determinant, so I'll just put this. Okay, this is equal to negative 2 I hat, and then you're going to have other stuff after it. Okay. However, if you did B cross A, then you have I hat, J hat, K hat, and you're going to have now 0, 3, 4 is going to be the first vector, and your second vector is going to be 0, 1, 2. Okay. And when you find the determinant of the first 2x2 matrix that you set up, okay, you're finding the determinant of the whole 3x3, but like each step is a different 2x2 matrix that you're finding the determinant of. That's kind of what I'm talking about here. Now, if we instead do B cross A, what happens to our 3x3 matrix is that, well, now B is going to be in the second row, so we have 0, 3, 4, and A will be in the third row, so we'll have 0, 1, 2. Okay, so if we're just trying to find our I hat here. I hat is now going to be 3 times 2, which is 6, or sorry, the coefficient on I hat is going to be, well, 3 times 2 is 6, minus 1 times 4 is 4. And we're going to have other stuff after that, of course. So this is going to be equal to 2 I hat. Now you see the difference here. Here we have a negative 2 I hat, but here we have a 2 I hat. So these are not going to be the same components. Okay, we have a negative 2 and a 2. And that's why we have to negate if we're going to switch it and do B cross A instead of A cross B, we have to negate it. Okay, that's the whole idea here. Now the second property that we're going to talk about is that if we have D times the vector A, okay, so D is going to be a scalar here, and we're going to cross that with the vector B. That's the same thing as if you can pull the scalar out here and have D times A cross B. And as you could pair it with just A and then do the cross product, you can also pair it with B and then do the cross product. So you can do A cross D times vector B. Okay? So you can just move scalars around. Scalars are not going to be, they're not going to do anything here. Okay? So with our third property here, we have that A cross, we have a B plus C, vector B plus vector C. That's going to be equal to, we have A cross B plus B cross C. Oops. Okay, so you can kind of see that you're basically distributing this cross product. So you can do A cross B and then do A cross C and then just add those two together. Okay, sorry here, this is supposed to be an A cross C. My bad. Okay, so for our fourth property, we have vector A plus vector B, and we're going to cross vector C. This is equal to A cross C plus B cross C. So basically what this is saying versus what 3 is saying is that if you're doing cross and your singular vector is second, okay, you can still distribute, okay? Just now your second vector in the cross needs to be that C, okay? So, you know, and that's important because, you know, why do we even care? Why is this fourth property necessary? Well, we have this A cross B equals negative B cross A, okay? So A cross B is not equal to B cross A, and that's why, you know, we need to be careful when doing stuff like this, okay? Of course, now here you see that you can distribute either way. All right, now our 5th property is going to be, well, we're going to actually talk about this more in another video, but the vector A, you can dot that with vector B cross vector C, and that's actually equal to A cross B dotted with vector C. And this is pretty interesting, and we'll actually be talking about that in another video. Okay, so now the 6th property, we have vector A cross vector A equals 0. And this actually makes a lot of sense. Okay, why does this make sense? Well, because vector A is pointing in the same direction as itself, right? You know, these two vectors are pointing in the same direction. They're the same exact vector, so they're parallel. Okay, that's kind of what they're saying. They're parallel. So the cross product will be 0. You know, and if you multiplied this by any scalar, you know, if it was like 3A cross A, it's still going to be 0. Okay, there's still two vectors pointing in the same exact direction. Okay, and the last thing is that if you cross A with the 0 vector, you're going to get 0. And of course, that works in the opposite way. So if you do 0 cross A, you get the same exact thing. Okay, and I'll just show you that real quick. If you have, say we have I hat, J hat, K hat, and then we'll do our A vector, which is A1, A2, A3, and then we have our 0 vector, 0, 0, 0. You can see that if we were to try to find the determinant of any of these 2x2 matrices that we would set up when finding the determinant of this 3x3 matrix, you're going to see that, well, you know, you have to multiply diagonally for all these determinants that you're going to be finding of these smaller matrices, and you'll get 0 for every single one. Okay, AD minus BC. Let's say we're talking about this 2x2 right here. Well, you're going to have an A1 times 0 minus an A2 times 0. You're going to get 0 both times. Okay, so you're going to wind up with a vector that is the 0 vector. 0, 0, 0. So that is the properties of the cross product. Now, did I really use these often, if at all? No, not really. I didn't use these, not that I can recall at least. Okay, yeah, it's great to know that if you cross something with a 0 vector, you get 0. That probably came up just a little bit. And if you cross something with itself, or something that is just like a scalar multiple, that's going to be 0. Okay, that might be something that you could see, but of course in number 5 that gets its own video, so don't worry about that. But you know, 1 through 4, I mean, no, I didn't use these too much. I mean, with number 1, that's just something that you know, you've got to know, so you don't mix that up on a test and do B cross A and expect that to be the same thing as A cross B, because it's not. Okay, but you know, it's just good to know these. You'll probably maybe have to do one of these or prove it, something like that, on like a cross product quiz or something like that, if that's something that you have. But yeah, that's gonna do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.